Hello, how are you doing? Some students email me and ask me a question regarding acceleration. Does acceleration decompose sometime when an object is traveling over a path? Please note when you have an object traveling or moving over a path, therefore this is a direction of the path. And in here you have an option of speeding up or speeding down, or keep your velocity or keep your speed constant. Sometimes you're not keeping your speed constant, therefore you have change in velocity, and the change in velocity called that acceleration. Therefore, that acceleration is gonna be inside a plane, which that plane, one axis of it is the axis that you are traveling, or the tangent vector, and the other axis is a normal vector. If the acceleration is in that plane, therefore that acceleration is a function of time and is going to be decomposed. Part of it go toward the direction is a t, this is a vector, this is a constant multiples, and another one is a sub n go toward the normal vector, and this is also a vector called a normal vector. Please note, if a sub n become equal to 0, 100% of the acceleration is in the direction of the object that is traveling, or in the direction of tangential vector. If a sub t becomes 0, 100% of the acceleration go toward the normal vector. What happens if neither of them are 0? You got to split them. Then we discussed this in previous chapters, that the tangential component is the projection of the acceleration over the tangent vector, which is the projection of a over a t. And remember, that should be a constant multiples. Therefore, this have to be a constant multiples. That constant multiples could be positive if the speed is increases, and that would become a negative if the speed is decreases. Therefore, this is equal to the formula. The projection is a dotted with a t over the magna of the t squared times a t. And we know that formula for projection. But because this has to be a scalar quantity, the dot product could be positive or negative. I'm going to write here as a dot with a t, but I'm going to take my magnitude square and I'm going to break it to 2 instead of square. And since it have to be a scalar quantity, this, what is the magna of the unit tangent vector, is 1. And what is the magna of that tangent, unit tangent vector, is 1. The answer is a dot with a t. And we know t is r prime of t over r magnitude of r prime. Therefore, the formula for tangential component is a dotted with r over r prime magnitude, or you do, I'm sorry, r prime, And you know this is A dot with the V or magnitude of the V. The dot product could be positive or negative. This is always going to be positive. Therefore, if this is negative, you are slowing down. If this is positive, you are speeding up. And we also proved for the normal component, we said there is not such a negative friction force. The friction force is either zero or positive. Therefore, that becomes the magnitude of A crosses with a V. We proved that formula over the magnitude of the V. Therefore, you have to know these two formulas that help you to find the acceleration, tangential component of the acceleration and the normal component. The question was asked, what happens if you have a path of t squared I plus 2tj, what is a of t at the t equal to 1? Well, this is a dot with a v over the magnitude of the v. What is v? Is r prime. 2t I plus 2j. What is the acceleration? Is 2I plus 0j. What is the dot product of these two? You gotta multiply these two plus product of these two. Therefore, that become 4t. The magnitude of the velocity is the square root of 4t squared plus 4. At the time of t equal to 1 will become 4 over square root of 4 plus 4. This is 2 times 4, which is 8. And the answer is become 2 square root of 2. That's make it 2 over radical 2. And that answer is a radical 2. Is this is 0? No. Therefore, you do have a normal component for the acceleration. Is this is positive? Yes. I guarantee you are speeding up. What is a sub n? You have to take a crosses with v, magnitude over the magnitude of the v. You have 2t, you have 2, you have a 0 for the k. You have 2, 0, 0 for the k. That is your cross product. What is your I component? 0. What is your j component? 0. What is your k component? 0 minus 4. 0 minus 4. And what is the magnitude of the velocity? The magnitude of the velocity is right here. Is the square root of 8. And that answer is 4 over the square root of 8. That's exactly the same as the tangential component, which is the square root of 2. Pretty much, you split your acceleration evenly in half. Half goes toward the tangential component, half go through the normal component. I hope I did all the math correctly, and I'm sure you are smarter than I am. If I made any mistake, you do the correction, but the process is right. You have to know this formula, and you have to know this formula. You have to know the tangential component could be positive or negative. Therefore, the dot product could be positive or negative. Dot product could be commute. It doesn't matter if you write A dot with V or V dot with A. In here, it doesn't matter. Somebody said, what happened if I commute? I'm going to end up with the negative vectors. Because you're taking the magnitude, it doesn't matter if you write A crosses with a V or V crosses with a A. The magnitude is always going to be a positive. If you switch these two, that becomes 4 minus a 0, and still you are going to have a 4. Thank you, and have a great day.